Hello, biology. Mr. Wegner here. We're going through our notes today for class Aves. Aves. So we started off our semester talking about mammals, and mammals was one of the classes of vertebrates. We're going to look at birds next, and then in our upcoming units, we're going to look at reptiles and amphibians. So we'll end up looking at several classes, not all of them, but right now we're on class Aves, which is our next unit. Aves means birds, of course. All right, let's see what we can do. You're going to take out your note packet. If you do not have the note pack, you can print it out, or you can stop and pick it up from school. It was available, I believe, on that first pickup in January. There'll be another pickup coming up in February for all the note packets or materials that you will need for the rest of February. So make sure and pick up those. Class Aves birds, if you do not have that, you can write it down, of course, write all the stuff down on paper if you don't have a printer. Class Aves, let's take a look and see what we got. All right. Ornithologist. An ornithologist is a zoologist that studies birds. Remember that zoologist is someone who studies animals, zoos where animals are kept. So an ornithologist is a specialist in birds. There are characteristics of birds. All of them are vertebrates, which is why they're in the subphylum Vertebrata. They all have feathers. They have wings, but not all fly. They have scale-covered legs. Homoectothermic, keeps their body temperature at one temperature. Endothermic, warm-blooded. So homeothermic is just a sort of or a brand of warm-blooded endothermic. We are also homeothermic. We keep our body temperature usually at 98.6. That's our constant temperature. They are designed for flight in the following ways. Following characteristics help birds for flight. Think about it, they actually have to fight against the forces of gravity that are pulling them down every single day. You can't do that unless you have some very specific designs. The same way an airplane cannot take off unless it has some very specific things about it. Its wing has to be shaped a certain way. It has to be made out of a certain lightweight material. It has to be aerodynamic. It has to have enough propulsion. All these factors have to figure in there in order for animals to fly. And God designed birds in a very specific, special way so that they're designed for flight. There are 9 of these characteristics. The first one is compact, lightweight, and very strong hollow skeleton. A hollow skeleton, not as strong as a solid one, but much more lightweight, enabling birds to take off. They have a nearly rigid backbone that gives a solid support for the strenuous muscle activity required for flying. All those muscles that flex and move the wings, they have to attach onto something strong. If it can't attach onto something strong, then it's not going to be able to do its job. They have hollow spaces in the skeleton that provide room for air sacs, which contribute to the efficiency of the respiratory system and make the bird lighter. So respiratory system, well, like our lungs, birds have lots of air sacs that allow them to hold and have lots of air always available so that when they're flying, their muscles get the oxygen that they need. For most of us, if we get tired running a race or we were exercising, we eventually have to breathe heavy so that we get more air in and out of our lungs. Birds actually have that automatically built in with these air sacs that have reserves of air right there already. So that's why birds are never like out of breath after flying a long distance. In addition to that, the air sacs actually fill them with air and make the bird lighter because air weighs almost nothing. Therefore, if much of their body is filled with air, it makes it lighter, it makes it easier for them to resist the force of gravity and fly. They're also bipedal, means two-footed. Bi means two, like a bicycle has 2 wheels, and ped means foot. If you're a pedestrian, you're someone who travels by foot. Or pedals of your bike. The pedal on your bike is where your feet go. So bipedal or bipedal is two-footed. This allows birds to have their wings free so that they can fly. They have something called a prominent keel or breastbone that allows for the attachment of flight muscles by strong tendons. That keel is that blue bone. We have one also, it's called a breastbone. It's called our sternum, but it's much flatter because we don't have really huge muscles that need to attach there. But birds do. Their breast muscles attach there. They have 3 bones in the shoulder that help support each wing. That's an important part of flight. They have lightweight beaks and skulls. Notice that they're different shaped. Why would some of these beaks be different shaped? Depending upon, obviously, what they eat. For like the F, That would be a seagull. It's going to scoop up fish from the water, and so it's got like a big flap coming, almost like a net. You've got other birds that have long, like the sea bird there, has a very strong, short one, probably for cracking open seeds. A has a curved hooked beak, probably necessary for digging in places to get insects or worms. All their beaks' shape are designed specifically for the kind of food that they eat. If you have like a D, a bird of prey, letter D, that's probably used for tearing off flesh. Very sharp, used for tearing. All right, so lightweight beak and skull. They also have a very efficient circulatory system, including a 4-chambered heart. We also have a 4-chambered heart. Not all mammals do. But all mammals have a 4-chambered heart, but not all animals have 4-chambered hearts. 4-chambered heart makes it very, very efficient for blood to get to the lungs, get its oxygen, come back and go out to the body. When we check out reptiles, we'll see that they actually have a 3-chambered heart, not as efficient. They have powerful muscles to power the wings during flight. There's a chicken breast there. That's obviously the meat that we eat, but that comes from the breast of the bird. And notice how big and huge and strong that muscle is. That's what you need to fight against the forces of gravity. All right, we also have 6 different groups of birds. By the way, all 9 of those characteristics of flight will be on the test, as will all of these different groups of birds and examples. So make sure you know those. Perching birds is the first group. These are 3 toes pointed forward, 1 toe pointing back. Leg has a special design that allows the bird to stay on its perch even if they are sleeping. Isn't that amazing? They can be on a small little wire balancing, and they can be asleep while they're doing it. God's designed them in a perfect way, just like that they can perch on either a branch or a wire. Some examples of perching birds are the thrushes. In fact, look at that. Right there, perfect balance. Look at how tiny and skinny those little legs are. And all that huge mass is holding up there. They can even sleep like that. It's an incredible design that God came up with to allow them to be able to sleep and not fall off based upon those tiny, tiny little feet and legs. Another example would be a robin. That's a perching bird. The bluebird would be another example of a perching bird. The goldfinch and the house sparrow. All of those are examples of perching birds. And the hummingbird. Notice again, 3 toes forward, 1 toe back. And the woodpecker, probably one of the most famous birds. The most famous woodpecker, of course, is Woody the woodpecker. He would have a funny little laugh. I can't do it, but Woody the woodpecker, he was a cartoon back in the 60s and 70s. He was very, very famous. All right, let's talk about our second group, birds of prey. Especially acute eyesight. They do that so that when they're flying way, way up above, they can spot field mice, snakes, other things that they're going to eat from super long distances. They have sharp, powerful talons. Talons, of course, are claws on the end of your feet. And they have a hooked beak, and that's used for tearing flesh. Do the chickens have large talons? They do, but they do not have the hooked beak. Vultures would be an example of a bird of prey. Notice the hooked beak. They are often called carrion in that they will often, scavenger birds, they'll often eat dead animals. God has designed the vulture with certain kind of enzymes in its stomach where it can actually take rotting, decaying, and dead flesh, dead meat from other animals and actually still digest it without getting sick. So a really neat characteristic of vultures. The California condor has one of the largest wingspans, about 7 feet. The sea eagle, you can see a good picture of the talons there as it's picked up a fish from the water, actually sees the fish under the water, flies down at super speed, reaches down under the water, grabs it with its talons, and pulls back up again. Quite an amazing feat. And of course, our national bird, the bald eagle. Notice again those really, really sharp talons. You can see them really clearly there, and the hooked beak used for tearing flesh. And again, very, very powerful eyesight. Eyesight is probably the most powerful sense between smell, touch, taste, sight, hearing. Sight is the most prominent sense in birds. And the golden eagle, which of course is the mascot for Marquette. Hawks are also in that category. Look at the big, sharp, curved beak. The osprey, that's a marine-dwelling bird of prey, but it lives out by water. And the falcon, the peregrine falcon, of course, one of the fastest animals on the planet. When it gets up high enough and it starts going fast enough flying, it can actually go down in a dive where it not only adds its speed, but also the speed of gravity pulling it downward. And it can reach incredible speeds. I want to say about 150, 160 miles per hour at its top. So the fastest animal, period, on the planet, a peregrine falcon. Owl. Owls are also birds of prey. They have a special characteristic where they actually have separate vertebrae in their neck that allow their neck to turn 180 degrees all the way around so they can see exactly behind them. And very, very cute eyesight also, and good hearing also for an owl. But they are also birds of prey. Another group, swimming and wading birds. Many have water-repellent feathers, webbed or lobed feet for swimming. Some birds have very long legs designed for wading. So swimming and wading birds. And of course, some examples, best example is going to be the duck, a mallard and a drake there. Geese, notice again the webbed feet, water-resistant feathers so that they can float on the water. The stork, according to legend, of course, the stork brings babies. Wouldn't that, you wouldn't want anything like that showing up at your door. Look at how ugly that thing is. But that's a stork, and it is a wading and swimming bird. The heron is another example of a wading bird. It doesn't really swim as much as it kind of wades through the water and picks out fish. Flamingos. Flamingos are actually also wading birds. Their pink color comes actually from their diet of what they eat, the food that they eat. Cranes are another example. Notice how the knees are bent backwards. Our knees bend forward. Those bend backwards. The egret is another example of a swimming and wading bird. And let's talk about some game birds. These have been hunted for food and sport. They have very large flight muscles, breast meat, that allows them to burst into flight. If you're ever going hunting for birds specifically, you're probably hunting for a game bird. And they're often the birds that we almost always eat. So let's take a look. Quail is an example. He's got that funny little hat going on there with his feathers, but big, large breast muscles, good for meat. The pheasant, we hunt a lot of those in Wisconsin, especially in Iowa, where I grew up. That's called the ringneck or collared pheasant because it's got a white ring or collar around its neck. The partridge. The grouse, some people go hunting for grouse. Doves. Doves are actually also used there for their meat. These are game birds. And of course, the turkey. Turkey is a game bird because it's one that we mainly eat. It has very large breast muscles. All right, there's also a group of birds called tropical birds. They live in the world's tropical forest. They are almost always brightly colored. Many have large, unusual beaks. The bright coloring is actually camouflage. You say, wait a minute, well, if they're really brightly colored, how can that blend into the surroundings? Well, remember, if you're in tropical settings, in the tropics, you often have very brightly colored flowers all around you. Red, green, blue, bright flowers. One of the most famous flowers is called the bird of paradise. It actually kind of looks a little bit like a tropical bird. But their bright colors, red, green, yellow, blue, allow them to blend into the flowers that are around them in the tropical settings. So that's camouflage. Such as the parakeet. The toucan, of course, the most famous one is Toucan Sam. He's for Fruit Loops. Notice he's got the big brightly colored beak as well. The macaw, that's the one that we think of very often. He's got the red, blue, and white feathers there. And then there's another group called the flightless birds. They have wings or wing-like structures, but they don't fly. Usually equipped with powerful legs for running. So these are still birds because they have wings and feathers, even though they do not fly. Such as the ostrich. Here there's actually ostrich races. I'm not sure where that's at. I think it's down in Texas, where they actually will climb onto ostriches and ride them in races like they would a horse. The emu, again, notice that all the muscles are actually in the hind legs, not actually in the breast. The kiwi is another example of a flightless bird. The penguin, another example of a flightless bird. And even though they can't fly, they are incredibly good swimmers. So they will swim. They still have feathers, and they still have wings. And then there's finally a last group, which is called the extinct birds. And these are birds from all different categories that have simply gone extinct. Pressure put on them on their habitat. The number one cause of extinction is the places where these animals live get taken over by man, and then they have nowhere to live, and then they eventually die out as a species. Some have been extinct for thousands of years. Some have gone extinct just recently, within the last 100 years or so. Some examples is the dodo bird. It was around in the 15 and 1600s, and there are some examples of it and skeletons of it, but it's no longer in existence today. The moa, this is a prehistoric bird. They don't have any they have fossils, but that's all that they have. The moa. The great auk, this is another one that was around in the 1700s, I believe, and went extinct then. I believe it's 1700s. The great auk. The passenger pigeon, that one became extinct, I believe, earlier at the beginning of the turn of this century. No longer any passenger pigeons on our planet. And here's another dinosaur one called the Archaeopteryx. Archaeopteryx, we just have fossils of it only. Archaeopteryx. Diatryma, this is another prehistoric bird, thought to be that big that it could eat horses. Again, we have bone records of it. And again, flightless because it had the huge, large leg muscles, not so much for the breast muscles. And it did still have wings also. All right, let's talk a little bit about family life of birds. Migration. Generally, migration in flocks. Migration, of course, is when you leave a colder area to go to a warmer area. They can migrate short distances or they can go thousands of miles. Many that migrate long distances need to pack on extra energy before starting the journey. Here's my picture here. So what are we talking about by pack on extra energy? Well, example would be like the hummingbird. It goes from 3.25 grams, that's how much it weighs before its flight. It goes all the way up to 6 grams. It almost doubles its body weight, almost, before it migrates across the Gulf of Mexico. It usually lands at about 2.5 grams. So almost twice of its body weight when it lands is used for fuel to get it across the Gulf of Mexico, because there's really nowhere to stop once you start swimming across that big body of water. They can't just land in the middle of the water, so they just have to keep going and going and going nonstop. And so they need lots and lots of energy for that. And again, migration is always north to south. Always north to south. You always go from a cold climate to a warmer climate. And then when the climate you're in gets cooler, you go back up north. It's always north to south, never east to west. Migrate about 300 miles. One of the shortest would be the American blue grouse. It just makes a small little trip where it's just a little bit more warm. Another one is the Arctic tern. It migrates 11,000 miles each time, literally from the Antarctica to the Arctic, from one end of the globe to the other. One of the longest treks of migration ever. It is seasonal and again depends upon the temperature usually. Migration can migrate slowly or in one continuous flight. Sometimes birds will make little stops along the way. Other times, if you're flying across large bodies of water like the Gulf of Mexico, like an entire ocean, you just have to keep right on going, nonstop. No rest at all. Sometimes they will catch thermal updrafts or they'll catch wind currents where they can like coast for a while, and that's always beneficial for them if they can get high enough where they can find the right wind patterns. But in some of those cases, they just have to keep going and going nonstop. Some examples are the red-winged blackbird. This is a slow migrator. It takes its time. It goes a little ways, plops down maybe for the night, goes again, slowly migrating. And another one would be the golden plover. This one flies nonstop for several days. It goes from Canada to South America, and it just keeps going and going and going like the Energizer Bunny. That would actually be a better example than the Energizer Bunny would be one of these birds that just migrates for days and days and days on end, never stopping. Many mysteries still abound in understanding migration. This is what we do know. Migrating birds follow the same route each year. My guess is more than likely that if you're at your house and you're going to like your grocery store or to Walmart or even to school, my guess is most of the time you probably pretty much follow the same route. It's very unusual for people to say, oh, I think I'm going to drive out of my way and go a different way this time. Maybe you do that on occasion. But in general, people are creatures of habit. They usually follow the same path. Birds are the same way. They almost always follow the same route every year. They can get a sense of direction using recognized landmarks. So in other words, like giant trees or certain skyscrapers, giant mountains can serve as if you're flying down from Canada and you want to go to South America, you can follow the Rockies or other sets of mountains that give you direction and landmark. Stars and constellations can also be used when they're flying at night. They can actually use the stars and know whether or not they're headed north, south, east, west. Some birds have something called magnetite. It's like an iron ore in their beaks, which allow them to use the Earth's magnetic field. Isn't that crazy? They actually can sense the Earth's magnetic field that runs from north to south, and the magnetite in their beak allows them to know whether or not they're heading in the right direction. Just like a compass needle will always point north, their beak will tell them, yep, I'm heading north, yep, I'm heading south. The amount of daylight can trigger migration. Obviously, when the daylight gets shorter, that's also when it gets colder. And when the days get shorter, then they realize it's time to go to a warmer place. The urge to migrate can be linked to breeding. So very often certain animals breed during certain times of the year. Migration is often linked to that. And it generally occurs in the spring and the fall when they go from cold weather to warm weather. And then once again, when their warm weather returns to their home region, they fly back north again. Migration is almost always north to south, hardly ever east to west. There's no benefit in going east to west because it's going to be the same temperature. You actually have to fly south to get warmer and north to get back to your home area. Let's talk just a little bit about courtship. Males can establish territory. The males have unique colors, plumage, and or songs that help to attract a mate. Some birds mate for life, and some of them only mate for a single season. They just hook up and then they find someone else next year. Some of them have very long engagements, but it's usually the male that seeks out the female, trying to put on a display, either with colors or songs or something, and then the female hopefully says, yep, that's a good mate, I want to be with that person. The frigate bird. So notice he's showing off his big red throat, I guess, that's all red in color, and that's supposed to attract the female. You notice that she looks like she's really not very interested, but who knows what bird psychology is. But anyway, that's the reason God gives them these certain characteristics or songs or abilities. They're simply trying to attract a mate. The greater prairie chicken is another example there. Mating and fertilization. Mating occurs after courtship. You know what? Actually, we're going to stop right here. This is as far as we're going to go today. So when we come back, we're going to pick up mating and fertilization. That'll be our next category. So this is all for our notes for today. Make sure you follow whatever else we have to do in our daily folder. And take care. God bless. Have a really great day.